At the Laboratory of Intelligent Systems, we aim at creating bio-inspired flying robots. Unlike this ground robot, aerial robots are capable of flying above obstacles. This allows them to have a non-obstructed view of the environment and to interact freely in open space. In addition, flying robots usually do not get into the way of people. However, designing autonomous flying robots is not an easy task. Challenges include designing the platforms, making them navigate autonomously, and actually doing something useful. To address these challenges, inspiration can be taken from nature, where animals can efficiently navigate and self-organize in nearly any environment.
The first step in making a flying system is to create a platform. As an example, the following robot can jump over obstacles, unfold its wings, and glide over large distances, much as certain animals. The motivation is to use little energy while being able to navigate in cluttered environments. For the wing deployment mechanism, inspiration was taken from the bat. The resulting glider is capable of unfolding its wings in just 50 milliseconds. Similar 1.5 gram gliders have been shown to fly 6 times further than the initial height from which they were launched. The mechanical design responsible for achieving very high jumps was inspired from the desert locust, which is a champion among jumping insects. The resulting robot is capable of jumping more than 27 times its own size, and the power consumption is minimal, since the entire system can jump and subsequently glide 105 times using a tiny battery. Finally, the aimed integrated system is very light since it weighs only 10 grams.
Once the platform has been designed, novel control algorithms must be implemented to allow the robot to autonomously navigate in its environment. Classical autopilot solutions, however, cannot be considered because they are too heavy and consume too much energy. Instead, inspiration is taken from the fly, which is capable of agile and precise flight using optic flow. Optic flow is a measure of how fast an image is moving on the retina of an eye. High optic flow is an indication that an obstacle is present nearby. Serving the same functionalities as the fly's eyes, aerial robots are equipped with simple linear cameras, allowing them to see forwards and below. Optic flow is then used to avoid walls and the floor, thus achieving 3D autonomous flight. Similar techniques can also be applied to outdoor aerial robots.
The next step, after building the aerial platform and implementing autonomous navigation, is to have the flying robots perform useful tasks, whether indoor or outdoor. One application of interest consists in the deployment of emergency communication networks in disaster areas using a swarm of flying robots. Again, inspiration was taken from nature. In particular, social animals such as these ants are capable of self-organizing to find paths to food sources using only very simple local interactions. In a similar manner, a flying swarm of 15 robots is able to create and maintain a communication network between 2 users using only local communication and simple interactions in simulation and eventually in real-life scenarios. Similar principles can be used to deploy sensor networks to locate objects in indoor environments. Using very simple local interactions, quadrotor type platforms are able to search every room of a building. When entering a new room, our quads can attach to the ceiling and serve as an eye in the sky or a beacon for other robots.
In the end, natural systems are a powerful inspiration for the design of flying robots.